Good morning to all of you. In the today's class, we are going to study about the stone. In this topic, we are going to study about the characteristics and their testing. So on the basis of this, we can verify their properties. So today we are going to study about that is the test on stone. Basically, stone is the hardest material which is used in the most of the construction material for the construction of road, buildings, beam, column, staircase, water tank, etc. To justify these properties, that is the hardness, the water absorption, the particular tests are decided. On the basis of the test result, the properties of stones are decided. So on the tests which are going to conduct on the stones, or which we are going to study, that is the crushing strength, to find out the strength and the compactness of the stone. The water absorption test, that how much percentage of the water absorbed by the stone. Then next is abrasion test, to find out the wear and tear due to the continuous impact and continuous contacting action between the stone particles or stones or the other material. So that on the basis of this, we can decide the particular type of stone should be used on the pavement surface or not. Then the impact test and the acid test. So first test is the crushing strength test. In this test, a random sample is taken having the size of 40 mm by 40 mm by 40 mm, which is taken from the parent stone. Then the sides of the stones are finely dressed and placed in water for 3 days. That means the dressing work is done so that the even surface of the stone can be obtained. That means by the dressing principle, the stone make it in a regular stable shape, uniform surface, and then it is placed in water for 3 days. The saturated specimen is provided with the layer of plaster of Paris on its top and the bottom, and the surfaces to get even when the load is applied on the stone will be distributed uniformly. That means if a stone having an irregular shape, then a plaster of Paris layer is applied on the top and the bottom, so that if the load is applied on the stone is distributed uniformly. If the load is not distributed uniformly, then the undistributed load is applied on the stone, and due to which the exact or the accurate strength of the stone cannot be obtained. Then a uniform load is distribution can be done by the satisfactory by providing a pair of 5 mm thick plywood instead of using plaster of Paris. That means a wooden plank of size this and this is placed on the stone so that the uniformly load can be distributed on the stone. The specimen is so placed in the compression testing machine is loaded at the rate of 14 Newton per mm square. That means the load is applied at 14 Newton per mm square per minute. Then the crushing load is noted. Then the crushing strength is equal to the crushing load divided by the overall area on which the load is applied. That means the load applied on the surface having the value in the Newton or the kilonewton and is divided by the area which is covered by the load specimen and on which the load is applied. On the basis of this, the strength of the stone is decided. At least the 3 specimens should be tested and the average of these values should be taken as the crushing strength. That means it is the machine or called as a UTM, which is called as Universal Testing Machine, in which the crushing strength of the stone is found out. So let us know how the crushing strength is found out. The specimen is tested and at which the stone starts break or the cracks form, then at which load the cracks start form is noted, and it is considered as a crushing strength of the stone. Let's see it again. That is, the load is applied and at the point the stone breaks, the value of the load is noted down. That means the capacity of load carrying by the stone is noted. and at which the stone cracks or breaks, that point is noted and it is considered as the crushing strength of that stone. Next, the water absorption test. The water absorption test is carried out to know the water absorbing capacity of the stone. If the water absorption by the stone is more than the adequate limit, or the percentage that should be absorbed by the water is not used or not considered for the construction work. That means if the water absorption is high, that means the stone must be porous or hollow inside so that it is absorbing more water. And if the stone is compact and solid enough, it is not absorbing more water than the adequate limit, then it is used in construction work or mainly in docks and harbors, because in the docks and harbors the most of the stone are facing or in covered with the water surface. So the water absorption test is done on the basis of IS code 11241974, which is the IS code recommended for testing of a stone for water absorption. For this test, the test cube specimen about 50 grams are prepared and the test is carried out. First one, that is the noting down the weight of the stones which is in dry condition. It is called as W1, or we can say that the dry weight of the stone. Now the specimen is placed in water for 24 hours at a room temperature, that is mainly 20 to 30 degrees Celsius. Then afterwards the specimen is taken out, which is weep out the surface of the stone having the excess water by the cloth, and now the again the weighing the specimen, which is called as W2. That means let us get very clear about the water absorption from the video. That the random 3 samples are taken, and on the basis of this, the weight of the 3 sample is noted down in the weighing machine. Afterwards, the stone specimen is placed in oven at a degree of 105 degrees Celsius for 72 hours, so that make it free from any moisture or loose material present in it, and making the stone 100% dry. After the 72 hours, the stone is taken out, kept at a room temperature for 3 to 4 hours. Then afterwards, it is putting into the distilled water for 24 hours without any disturbance, so that the stone completely immersed in water, all the pores and the holes can be filled by the water and the stones become 100% saturated. Then the stone sample is taken out and it is cleaned by the cloth so that the excess water present on the surface can be removed. Now, again weighing the stone piece called as W2 and finding out the water absorption. That means the W1 is the dry weight of the stone before immersing in the water, and W2 is the wet weight of the water which is taken out the sample after the 24 hours immersed in the water. Now, the water absorption is the difference of the wet weight, that is W2, and the W1. That means the difference weight is the weight of the water absorbed by the stone. For finding out the percentage, the difference weight, that is W2 minus W1, is divided by W1, that is the dry weight of the stone, multiplied by 100, gives the value of percentage water absorbed by the stone. For a good quality of stone, it should not absorb water more than 5%. That means a good quality of a stone absorb less than 5% of water by weight. If the stone absorbing water more than 5%, then it is considered as a stone which is porous in nature, having potholes, having some pores. That means it is hollow in nature and it absorbs more water, and it will harm our structure if we use in construction work. Then the next test is the impact test, which is done on the basis of IS code 2386-1963. To find out the resistance of stones to the impact is found by conducting the test in impact testing machine. The impact testing machine is used to find out the impact test. That means how much compactness and solidness in the stone and how it is strong inside to resist the outer load acting on it. Mainly, it consists of a frame with the guides, which is in metal hammer, having the weight of 13.5 to 15 kg, and it is freely fall from the height of 380 mm. Now, the aggregate of size 10 mm to 12.5 mm is filled in the cylinder, which is in equal 3 layers, which is tempted by the tamping rod in 25 times. That means each layer filled 3 times. That means the cylinder is filled in 3 layers. After filling each layer, it is tempted by 25 times by the tamping rod, and then it is completely filled. The same is transferred in the cup, and then tamping done is 25 times. The hammer is allowed to fall freely on the specimen is 15 times. This is the machine in which the impact test of the stone is done. This is the hammer, which is having the weight of 13.5 to 14 kg. The height is 380 mm, from which the hammer is freely falling. This is the tamping rod by which the tamping is done 25 times. This is the mold or the cylinder in which the aggregate are filled, having size of 10 to 12.5 mm. The particle size is lies between 10 mm to 12.5 mm, and it is filled in the cylinder, which is the cup or the mold on which the impact testing is done. It is filled in 3 layers. After filling each layer, it is done tamping by the tamping rod 25 times. Then the hammer is allowed to fall freely on the cylinder 15 times, so that due to the free fall action of the hammer on the stone resists to take the load without any failure, without any cracks formation, and which is done in 15 times. Then afterwards, the stone piece are taken out for the calculation of further result. So this is the impact testing machine for finding out the impact test on the stone. This is handle. This is the hammer. The size of the hammer is 10 centimeter in dia and fall from 380 mm height, impacting the cylinder 15 times. Now, after the 15 times the free falling of the hammer is done, the specimen is taken out and the stone pieces are sieved in IS sieve 2.36 mm size. Now, weighing the weight of the stone pieces which pass through the 2.36 mm sieve. That means the material which is coming out from the sieve is collected in a cup or the mold, and the weight of the material collected is noted down. In this procedure, the original weight of the stone before the impact test performed is taken as W1, and W2 is the weight of the material which passed through the IS 2.36 mm sieve. Now finding out the aggregate impact value is the ratio of W2 by W1 into 100, which gives the value of impact on the of the stone, and if the result lies then 10%, then it is considered as a exceptionally strong, which is used on the top surface of the pavements, in the beams, in the column. If the value lies between 10 to 20%, then a stone is considered as a strong. It cannot be used on the top surface, but it can be used on the below the top surface, or in the beam, or in the column, or the slab, water tank, etc. If the value lies between 20 to 30%, then it can be used as a filling material in the bottom layer of the foundation or in the bottom layer of the pavements. But if the percentage value is greater than 35, then it cannot be used on the road surface, or it cannot be used in any construction work. So on the basis of the test result, the impact value is decided and the material can be used for the further work. So in the today's class, we have studied about the first one, that is the crushing strength. The second one is the water absorption. And the third one is the impact value test. In the next class, we are going to study about the abrasion value test to find out the wear and tear of the stone. So that's it for today. We will continue in the next class.